Okay guys, here's the second part of the video. I'm just going to go through some of the... I'm just going to go through some example questions specifically on sine ratio. Hopefully once I do sine ratio, it'll make a little bit more sense of what I mean by the SOHCAHTOA thing. Again, guys, if you guys did not get that last video, please go over it again because that's super duper important. And it's, if you can't move on unless you know it, right? So the thing is I'm going to show you on a basic calculator. Like I'm just going to look up that one I did on Google last time and use that calculator to show you how to do the calculations. Yours might be different. So again, I can't stress the importance of you guys actually trying these equations too in your calculator. Please do. That's all I'm asking. Please actually do it. Okay. So the sine ratio can be used to find lengths and angles in right triangles. In the right triangle, the sine ratio of each non-right angle is given by sine A is equal to opposite over hypotenuse. You see how this is different this time? Last time it was like the theta. That's okay. Okay, this is just now telling us specifically what angle we're talking about. So this case, it's saying sine A. That means we're talking about angle A. So this is our angle of interest. That's what that means. So then from here, now that we have our angle of interest, we can label our triangle. So we know that this is my hypotenuse. This is my opposite. And this is my adjacent. Okay? So that means for us to be able to solve for this angle, we have our hypotenuse. So we would have this side, a known side, and we would have our opposite. Okay? So I'll give you a couple of examples. So when working with a right triangle, and the two sides that are given are the opposite and the hypotenuse with respect to the given angle or the angle of interest, the sine ratio is used. For every trig ratio, there is an inverse ratio, and it is used to calculate angles. Okay, so where can the sine ratio be used? And then we'll get into the math part. So what you're going to do here is you're going to label. Here's my angle of interest. So before we even look at the numbers, let's label our triangle. So we have our hypotenuse, we have our opposite, and we have our adjacent. So to solve for sine, remember So sine theta, that's just to represent any angle, is equal to opposite over hypotenuse. Okay. Do we have our opposite value? Yes, we have a 25, so we can use it here. So far we can use this, right? I lied to you. I jumped the gun there. Here's our hypotenuse. Do we have a value there? Yes. Okay. Now, yes, we can use this triangle to solve this angle here, okay? Because we have enough information. Okay, let's go to the next one. Again, I'm going to quickly label them. There's my angle of interest, so there's my opposite. Oh my god, that's the second time I did that. Here's my hypotenuse. Here's my opposite. Here's my adjacent. Okay, let's take a look. What's my equation? Sine theta is equal to opposite over hypotenuse. Okay. Do I have an opposite value? I do. Do I have a hypotenuse value? No, I don't. So I cannot use sine to solve for that triangle. I would have to use one of those other ratios that I was just showing you. Okay? So the question is, can I use sine? No, I cannot. Don't worry about solving it right now. We're just focused on sine. Let's do it again. Here's my hypotenuse. Here's my opposite. Here's my adjacent. Okay, so sine is equal to opposite over hypotenuse, right? Because if so, do I have an opposite? Nope. Can't even use it. We can't use sine. Okay, and that's okay. Once you are taught all of them, then you're going to have to determine which one's which. Okay, use your calculator to find each value to 4 decimal places. So, looking up some supplements. Okay. Calculator. Online calculator. Oh, no, I don't want to use that. There. Okay, let's take a look. So I'm in scientific. I have a scientific calculator. I want it in degrees. It does make a difference. Okay, DEG. See, I'm pretty sure this is DEG because it's selected. So what was my question? Sine 42. So the way that we have to put it into this calculator, we can't. Actually, no. The way sometimes you have to do. So if I were to do sine 42, it works fine. Okay? Sometimes you have to type in 42 sine, and it really depends on your calculator. The answer I got was negative 0.9165. Okay, I think my calculator's in radians. Yeah. There. Let's try again. There we go. So sine 42 is equal to 0.6691. Okay. .6691. So you either have to type in sine, so the button sine, for 2. Or it's 4, you type in 4 2 sine. Okay? It depends on the type of calculator you have. So try the first way. Try this way first. If it doesn't work, try the other. If you don't, send me a picture of your calculator and I'll tell you how to do it. Okay, so next one, sine 33. Clear that. So sine 33 equals 0.5446. Remember, I did say to 4 decimal places. Let me see if this works. Hold on. Copy. Oops. Okay, no, it's not working. Anyways. What did we say? We said 0.5. Okay, there we go. Again, guys, try this. Don't just watch me and be like, okay, it makes sense. Put it in your calculator. Okay, because if you're doing your work at like 3 in the morning and you're like, oh, I'm stuck. Yo, Miss B, and I'll be like, I'm snoozing. So, yeah. Okay, so this one is going to be slightly different. Use your calculator to find the measure of each angle A to the nearest degree. So this one's going to look a little different. Again, depending on the calculator you're using. So we have sine A, 0.6083. So essentially what we're doing is we're solving for this A here. Well, we can look at it like left side, right side. Sorry. Is A by itself? No. So naturally, we would do divide by sine, right? Because then that would go boom, boom. So we do 0.6083 divided by sine. Unfortunately, sine doesn't work that way. Neither does cos, neither does tan. So we have to do it a little bit different. So it's good for you to recognize that A needs to be by itself. But it's going to look like this. The opposite of sine is sine to the minus 1. Okay, so what you'd have to type in would be sine to the minus 1 bracket 0.6083. Now I'm going to show you. So here, we don't have, I don't see it. I'm just trying to clear that. So here's our sine, but we want the inverse sine. We want the other one. Okay, so I need to find the scientific one. Tricky. I don't know how to do that. I thought it would be just push of the button. That's usually what it is. Look on your calculators now, guys. Usually your sine to the minus 1 is above your sine. Now, it might be in a different color. So, for example, with mine, my sine to the minus 1 is in like a purpley color. If you look at the top, it's usually the top left of your calculator. It'll say second or shift. You have to push that button first. So you push it, and then you push the sine button, and it should say sine to the minus 1. If I can't do this, I was really hoping I could just change this one. Let's do scientific calculator online. Scientific calculator online. Didn't even work. Let's see what this one's about. Okay, here we go. So, as you can see in this calculator here, sine to the minus 1 is already in there. So this one's going to be a little bit different. So if I were to type in sine to the minus 1, 0.6083, oops, 0.6083, there we go, 37.4666. It says to the nearest angle, but it's technically 38 degrees. Because the 6 would round the 4 up to a 5, and the 5 would round up the 37 to a 38. So as you can see, guys, you have to type in, now again, your calculator, now this is what's going to be hard about the distance learning. If you want to use the exact calculator that I'm using, go for it, okay? It would be so much easier with respect to explaining, but really depends on what you have. Okay, how do I clear that? There we go. Okay. And it would work for the other ones, like if I did the sine 42, it's the answer that we wanted, right? Okay. And you see, look, you see how that's radians? We want degrees. You might have to do a little work on your calculator to figure out what that means too. Okay. Same thing here, sine A. As you can see, we're solving for this guy here. That means we have to do sine to the minus 1, 0.1425. Okay? So sine to the minus 1, don't worry about that arc sine, okay? Don't, just ignore it for now. 0.1425. Says to the nearest degree, it says 8.19. So the nearest degree would be 8. Okay. 8 degrees. Sweet, eh? Oh, so cool. Okay, so use your calculator to find each value to one decimal place. Because I just explained the ones up top, I'm not going to explain them again. I'm just going to give you the answers for these ones. Okay? So, do them. I want you to actually learn this, guys, because as I said, you're going to use them next year. This does technically say to 1 decimal place, so that would be there and there, but whatever. Okay. So, check your answers. Okay, so what I'm going to do is I'm going to go through different examples, 4 different examples with you. We're going to use our SOHCAHTOA, well, our sine, because we're just dealing with sine today. And then tomorrow, pardon me, sorry, I need to get a coffee in me. Tomorrow we will move on to cos and tan, and then next week we will go into, I'm not going to tell you which ratio to use. You're just going to we'll have to figure out based on the information we have. Okay? Okay, so find the measurement of the missing side of a triangle. Round your answer to 1 decimal place. So, as you can see, we need to find this guy. So that is a side. So we need to look at our angle of interest. We know it's right here. We need to figure out what we have. So we have our hypotenuse, and we have our opposite. Or that's what we're looking for anyways. So if we set up our SOHCAHTOA, we know we're dealing with sine, so I'm just going to tell you we're dealing with sine, okay? So, sine theta is equal to opposite over hypotenuse. So, do we have a theta as in do we have an angle? Yes, it's 26. So we're going to put that in there. Do we have an opposite? Well, our opposite is what we're going to be looking for. In this case, we determined it by x. So I'm going to throw in an x. Our hypotenuse, 64. Okay? So, now we need to solve for x. Now, again, this is like our left side, right side stuff. Okay? Is x by itself? No. Okay. Well, it's with a divide 64. What's the opposite of divide 64? Times 64. So we're going to multiply 64 by this side. Okay? So it's going to be 64 times sine 26. Another way that you can look at it too is if we use our method from the similar triangles, we can use our fishy. So sine 26 is technically a fraction. It's over 1. That's something you're going to need to remember. Because it's over the number 1, that will help us with our equations. So remember, we draw our fish. We always start with the letter that's like the unknown and the number associated with it. So our fish is going to look like this. Oops. Or it's going to look like this. So we're going to start with our 64, go up to our sine 26, down and around. That means it's going to be 64 times sine 26. Okay. Times sine 26 divided by 1, which is always just 1 anyways, which is equal to x. Now we've got x by itself. So all we have to do is solve for it. So 64 times sine 26 is 28.05. It does say to 1 decimal place, so 28.1, because the 5 would round the 0 up to a 1. Okay. And there is your value for x. Sorry, just having some water. Okay. Same idea. We're dealing with sine. Next lesson, I'm going to go over with cos and tan, something a little way that you can try to figure out which one's which, but I know I'm dealing with sine. So I'm going to do sine theta is equal to opposite over hypotenuse. So, new playground was built. Sarah was afraid to go down the slide. The slide is 3 meters long, and the incline of the slide to the ground is 49 degrees. Okay, so our triangle is going to be like this. If you guys need to do that to figure out which the triangle is, that's fine, obviously. How high was the slide off the ground to 1 decimal place? Okay, how high was the slide? Well, we know this is my height here, so there's my x. So, here is my angle of interest. So that means this is my hypotenuse. This is my opposite. And this is my adjacent. Okay, so sine theta, opposite over hypotenuse. Sine theta, what's theta? Theta is 49. What's my opposite? It's x again. What's my hypotenuse? 3. Okay. I'd say the hard part's done. So, remember this is over 1, and we're going to set up our fish. 3 times sine 49 divided by 1 is going to give me x. Three times sine 49 divided by 1 is going to give me x. Oh no, what happened? There we go. 3, oops, sine 49 is going to give me 2.26412.87407. Rounded to 1 decimal place. The 6 rounds the 2 up to a 3. So remember, it's a word problem. The slide is 2.3 meters off the ground. Okay? Sweet. Let's do it again. Find the measure of P and round your answer to 1 decimal place. Okay. So, if that's our angle of interest, that means this is my hypotenuse. This is my opposite, and this is my adjacent. Let's set up our equation. Sine theta is equal to opposite over hypotenuse. What's my theta? Well, that's actually what we're solving for, is our angle. So if you could leave it as theta, or you could put it in as a p, because our angle p is what we're solving for. Okay? So, what's my opposite? 5. What's my hypotenuse? 21. Okay? So again, this is over the number 1. So again, we start with our unknown. What is our unknown? Our unknown is sine p. So we're going to go to the other one, and I'm going to make my fish. 1 times 5, oops. 1 times 5 divided by 21 gives me sine p. So 1 times 5 divided by 21 gives me sine p. Okay, so I'm going to do 1 times 5 divided by 21. 1 times 5 equals, divided by 21 is 0.2381. So I'm going to write that down. 0.2381. Okay, so remember, we're solving for p, not sine p. We're solving for p. Is p by itself? No. So we have to do the inverse of sine. That means it's going to be sine to the minus 1, 0.2381, which will give me p, because then that would get rid of this sign here. Okay, so it's a bit of a change. So sine to the minus 1. Oops, I want to clear that. Sine to the minus 1. What do I have? 0.2381 is 13.77. How many decimal places does it want? 1 decimal place, so 13.8. Centimeters. Okay. Okay, one more. Again, guys, please try these. I highly recommend you go through them before I even say it. Check your answer. Okay, a storm caused a 13.5 meter hydro pole to lean over. The top of the pole is now 11.8 meters above the ground. Find the measure of the angle between the pole and the ground to the nearest degree. Okay, so between the pole and the ground. So let's label our triangle. Here's my hypotenuse. It's my longest side, because this is my right angle. This is my opposite, and this is my adjacent. Let's set it up. Okay, do I have a theta? Nope, that's what I'm solving for, so I'm going to keep that in there. I could change that to a p if I wanted, so totally up to you guys. I have 11.8. It's my hypotenuse, 13.5. Remember, this is over 1. Let's do our fish. Actually, I lied too. We're just going to solve for this first. We don't have to do fish. So 11.8 divided by 13.5 is 0.8741. 0.8741. Okay, Is theta by itself? Nope. What's attached to it? The sine. So I need to do the sine inverse. Sine to the minus 1 crosses those two out, which means it's going to be sine to the minus 1 and then our number. Okay, so sine to the minus 1, 0.8741, I think that was it. It's equal to 60.9. It says to the nearest degree, that's a full degree, so that'd be 61. Therefore, the telephone pole fell at an angle of 61 degrees. Sweet. So guys, take your time with this. Put it in your calculator. Don't half-fast it. If you have any questions, let me know. But be specific about your questions too. Like, don't just say, I don't get it. Okay? You got to try it. You got to put the time in. Okay? See you later.